Okay, let us see from beginning. So file organization. So we are managing the file in the disk. Okay, how you are organizing means in order way you are arranging. If you are arranging order way, we can perform our operations easy way. So there is no data loss. If you are inserting, updating, deleting the records, should not harm to other records. So these are the advantages if you are arranging the files in organized manner. So what are the contents we are discussing here? File organization, comparison of file organization, right? Indexing, index data structures, tree structure indexing, institution for tree indexes, indexed sequential access methods, that is ISM, and B plus tree dynamic trees. We are tree structure we are going to discuss in the file organization and indexing data structure. First of all, we are going to discuss about file organization here. So file organization. So here the storing files in a certain order is called a file organization. The main objective of file organization is optimal selection of the records. That is, records should be accessed as fast as possible. And while you are inserting, updating, deleting the transaction of the records should be easy and quick, and should not harm to other records. And there is no duplicate record should be induced as the result of insert, update, or delete. So the records should be stored efficiently. So the cost of storage is minimal. Okay, some of the file organizations we are discussing here, those are sequential file organization, heap file organization, hash file organization, indexed sequential access method, and B plus tree file organization, cluster file organization. So these are the file organizations we are going to discuss in our session. So first one is what? First file organization is what? Sequential file organization. In this sequential file organization, records are placed in the file in some sequential order based on the unique key field or set key. So the easiest method for organization is sequential method. In this method, the files are stored one after another in the sequential manner. The files are stored one after another. There are two ways to implement this method. Those are, first one, file method, sorted file. So file method. This method is quite simple, in which we store the records in sequence, one after another, in the order in which they are inserted into the table. If you see the example, you can understand. This is the way we are inserting records in the file. See, this is R1, R2, one by one we are arranging all the records and so on. R5, and this is the starting of the file R1. So and the end of the file is R4. So here insertion of new record. This is now one record, right? One file. Now you are going to insert one record in this file. So while you are inserting new record, let the R1, R3, and so on, R5 and R4 be the 4 records in the sequence. Here the records are nothing but row in the any table, you know already. So records means what? Rows. File means what? Table. Okay. Suppose a new record R2 has to be inserted in the sequence, then it is simply pasted at the end of the file. See this diagram. So R1, R2, R5 and R4. Now I am trying to insert new record R2. Now I am trying to insert new record R2. It has to be inserted in the sequence. Now it is going to be inserted here. So it is inserted in the sequence. Then it is simply placed at the end of the file. Where it is going to replace? Where it is going to insert? So end of the file. Here it is inserted. So end of the file it is inserted. Understand? So coming to sorted file method. Okay, in this method As the name itself suggests, whenever a new record has to be inserted, it always inserted in a sorted, means ascending or descending manner. Sorting of the records may be based on any primary key or any other key. So sorted file method means the records arranged in sorted manner. See the sorted manner here. So you know already the records are R1, R3 and so on R7. So let us assume that there are 316 stored sequence of the 4 records. So R1, R3 and so on up to R7 and R8. Okay, till now we inserted the records in the file. So suppose new record R2 has to be inserted in the sequence. So I'm trying to insert new record R2, then it will be inserted at the end of the file. So it is also inserting in the end of the file. Okay, then it will be sorted in the sequence. Now how it is storing in the sorted order? Sorted order means, so one by one, alphabetical order, right? Ascending or descending order. So we are inserting R2. So now see here, see the both diagrams. So now trying to insert the R2 value here, R2 record. So it should be in ascending or descending order. So I'm inserting default is what? Ascending order. So now if you are trying to insert this R2 record, where it should be stored, where it should be the location should be, so in between R2, R1 and R3, right? So now it is inserted in between R1 and R3. Okay, now you are trying to insert new record. If you sorted order means, so R1, R2, R3, R7, R8. Understand? So that is sorted file method in sequential order. So next you can see the advantages and the disadvantages here. The pros and cons of the sequential file organizations. So the first one, the first advantage is what? It is fast. It is fast. So see here, are you getting my voice? Yes, all of you. Is it clear?
Yes, sir, we are getting one. Your voice.
Okay. Now see the advantages and the drawbacks from the sequential file organization. So the advantage is it is fast and efficient method for the huge amount of data. So when it is efficient, if you have huge amount of data in the file, so it is efficient and it is fast. It is a simple design, and the files can be easily stored in magnetic tapes, that is chapter storage mechanism, sorry, cheaper storage mechanism, very cheaper. And what are the drawbacks? So here the time wastage, as we cannot jump on particular record that is required, but we have to move in sequential manner, which takes our time. Okay, so whatever the records you are arranging, so you should follow sequential manner, one by one you should arrange. So it is a time waste process, we cannot jump onto particular record. If you want to particular record only, so we cannot jump here. So that is a time waste process. And the sorted file method is inefficient, as it takes time and space for the sorting records. This is taking time and space means memory. Memory is space. So that is about sequential file organization. The next file organization is what? Heap file organization. Next file organization is what? Heap file organization. When a file is created using heap file organization, the operating system allocates memory area to that file, and without any further accounting details, the operating system is allocating memory area for that file. Okay. So that is the heap file organization. Okay, file records can be placed anywhere in that memory area. The files is not storing in some place, so the file records can be placed anywhere in that memory area. Okay, heap memory area. Heap file organizations works with data blocks. So these will work with data blocks. In this method, records are inserted at the end of the file. So the records are inserting the end of the file into the data blocks. So no sorting or ordering is required in this method. Here is no sorting and no order is required here, like sequential file organization. Here not required the sorting and order. Okay, if a data block is full, so if the data block is full, then the new record is stored some other block, then the new record is stored in some other block. Here other data blocks need not be the very next data block. Okay, but it can be any block in the memory, it can be any block in the memory, it is the responsibility of database management system to store and manage the new records. This is the not responsible of heap file organization. It is the responsibility of what? Whom? Database management system. Okay, see here, these are the records and this is the data. This is the blocks. Okay, so these are the blocks, the data blocks. Okay, see here the data blocks. We are trying to insert new record. So suppose we have four records. In the heap memory. So R1, R5, R6, R4 and R3. So suppose a new record R2 has to be inserted in the heap. R5 is so R2 is, or we are trying to insert a new record here. To data, whatever the data block we are inserting, so those from the whatever the record we are trying to insert, so that is we can insert in the. So if the data block 3 is full, so see here we have 3 data blocks, right? 1, 2 and 3. So if 3 data blocks are full, it will be inserted in any of the database selected by the DBMS. Let's say the data block is 1. For example, see here we are trying to insert auto record. Now it is taking here. If the data block is full, third data block is full. Now what happens? The DBMS take care. What it is doing? The block 3 is full. It will be inserted in any of the database selected by the database management system. Let us say that is block 1. So now the value is inserted here in the first block. Okay, it is empty right here. So the database management system storing here. Okay, so now see what here if we want to set delete, update data in the heap file organization, we will traverse the data from the beginning of the file till we get the requested record. Thus, if the database is very huge, means if the database having so much of data, and the searching or deleting or updating the record will be take lot of time. Okay, so that is the drawback here. So we will see the advantages and the disadvantages of heap file organization. Here the advantage is what? The fetching and retrieving faster than the sequential record, but only in case of small databases. Small databases, it is easy to fetching and retrieving the records comparing to sequential file organization. The heap file organization is fast when if the database is small. Okay, when there is a huge number of data need to be loaded into the database at the time, so then this method of the file organization be best suited. Okay, what are the drawbacks here? The problems of unused memory blocks. The problems here what? Unused memory block and inefficient for the larger databases. Is not efficient for the larger databases. So those are the advantages and disadvantages of heap file organization. Sequential file organization completed. Next, heap file organization completed. Now we will see the hash file organization. Hash file organization. You know hash, right? In the Java you have seen hash table. Okay, that doesn't contains order, right? We follow hashing technique. So the hash function generates particular order. Okay, so hash file argument function computation on some fields of the records. The output of hash function determines the location of the disk block where the records are to be placed. Method of file organization, hash function is used to calculate the address of the block to store the records. Okay, the hash function can be any simple or complex mathematical function. The hash function is applied on the some columns or attributes, either key or non-key columns to get the block address. Hence, each record is stored randomly, irrespective of the order they come. Hence, this method is also known as direct or random file organization. Direct or random file organization. So if the hash function is generated on the key column, then that column is called hash key. Okay, and if the hash function is generated on non-key column, then column is called hash column. Okay, so see the data records and data blocks in the memory. So data records R1, R3, R6, R4 and so on and R5. So here the data blocks are hash values. See here, when a record has to be retrieved based on the hash key value, hash key column, the address is generated and directly from that address whole record is retrieved. By using that address, whole record is we can retrieve. So here no effort to traverse through the old file. Similarly, when a new record has to be inserted, so the address is generated by the hash key and record is directly inserted. The same is the case of update and delete. Now what is happening while you are inserting a new record? The address is generated by hash key. Okay, while retrieving or while you are inserting a new record, the hash key is generated by the address is generated by the hash key, and the record is directly inside it. Same for update and delete. If you are trying to update, performing update operation, the address is generated by hash key. While you are deleting, the address is generated by hash key. Same for all. Okay. Now that's what here, and the advantages of hash file organization. The advantages of hash file organization. So what are the advantages? So the records need not be stored after any of the transaction. Hence the effort of sorting is reduced in this method. Okay, and since block address is known by the hash function, accessing any record is very faster. Okay, similarly updating or deleting record is also very quick. So, and then this method can handle multiple transactions as each record is independent of other. That is, since there is no redundancy on the storage location of each record, and the multiple records can be accessed at the same time. It is suitable for online transaction systems like online banking, ticket booking system, etc. Those are the advantages. So see here, the next one is what? Clustered file organization. The next one, clustered file organization. Clustering means what? Combining. More than two files we can combine. Here, see cluster file organization. Clustered file organization is not considered good for large databases. It is not good for large databases. So in this mechanism, related records from one or more relations are kept in the same disk block. That is, the ordering of the record is not based on primary key or search key. It is not based on primary key or search key. So in this method, two or more tables which are frequently used to join, and get the results are stored in the same file called cluster. So clusters, these files will have two or more tables in the same data block, and the key columns which map these tables are stored only once. This method has reduced the cost of searching of various records in the different files. All records are found at one place, and hence making search efficient way. See, we have two tables here, student and course. Here student having student ID, student name, address, and course ID. The course table we have in course ID and course name. See here, common one is what? Course ID. Okay, see, based on this we are clustering. So what is the cluster key here? Cluster key is what? Course ID. Course ID is cluster key here. Okay, because by using the key we are able to combine two tables here, student table and course table. Okay, here combined here, see the table, the cluster file having the course name, course ID, and student ID, next student name, and the address we combined here. Okay, values also, right? So that is the cluster file organization. Okay, so these are the file organizations. So B plus T organizations we will discuss in the later session. Okay. uh, and then we have RAID, RAID, RAID. So RAID abbreviation is what? Redundant array of independent disks. Redundant array of independent disks. What is RAID? It's important question. This is also. So redundant array of independent disk. Redundant means duplicate. Arrays means is what? Collection of files. Those are independent disk. Those are available in independent disk. So those we can discuss here one by one. So RAID, redundant array of independent disk, or redundant array of independent disk is the technology to connect multiple secondary storage devices and use them as a single storage media. So this RAID consists of an array of disks in which multiple disks are connected together to achieve the different goals. Okay, so we are combining multiple disks here to achieve the different goals. So the RAID level defines the use of disk array. Okay, so we have different levels here: RAID level 0, RAID level 1, RAID level 2, RAID level 3, RAID level 4, RAID level 5, and the RAID level 6. And till here we will discuss. So we have RAID level 10 also, 15 also. Okay, but we will discuss till here. So see here, RAID 0. In this level, 0 level, the stripped array of disk is implemented. Array of disk, collection of multiple disk. So this is the controller. Okay, so we have one component called RAID controller. So it is controlling all the disk, number of disk. Okay, we have multiple disks connected with the controller. This controller is controlling the so that the data is broken down into blocks. Okay, number of blocks: block 1, block 2, block 4, and so on. And the blocks are distributed among the disk. The blocks are distributed among the disks. Each disk receives the block of data, write or read in a parallel. So parallel way operations are read or write operations are performing in the parallel way. It enhances the speed and performance of the storage device. So because of that, it is enhancing the speed and performance of the storage device. There is no parity and backup in the level 0. See, for fast accessing, see, we have multiple hard disks here. Okay, multiple hard disks. So in this hard disk is having 4 GB, 4 GB, 4 GB. So while you are storing and while you are retrieving, so it is fast. Okay, you are using multiple devices, right? If you are storing all data in one device, so the performance will be slow, right? So that's why here we are using multiple hard disk here. So because of that, the performance is good. Okay, speed and performance is good. Storing or retrieving, if you are performing write or read operation and all. But what is the drawback here? There is no parity and backup. There is no backup in level 0. If any data loss from one hard disk, so there is no option to retrieve that data. Okay, there is no backup. So that is the drawback of RAID level 0. So coming to level 1, the RAID 1 uses the mirroring technique. Here they are using mirroring technique. That means when the data is sent to RAID controller, it send a copy of the data to all the disk in the array. So it will send the all the copies from all the disk in the array. So if the my data is available in one disk, so if the disk is the data is available in two disks, means mirroring means copying. So this data available here and here, our data is available in this disk and in this disk also. And that means what? If this disk is failed, okay, the data lost, then we can get the data from this disk. So when the data is sent to RAID controller, it send a copy of the data to all the disks in the array. Then RAID level 1 is also called the mirroring and provides 100% redundancy in case of failure. So if it is failed to retrieve data from one disk, so it is 100% redundancy in case of failure. It provides 100% redundancy here. Okay, that is the advantages from RAID 1. Okay, coming to RAID 2 means level 2. RAID level 2. Here the record error correction code using Hamming distance for its data stripped on the different disk. Okay, and like level 0, each data bit in word it recorded on the separated disk, and ECC coded of the data words are stored in the different set disk. So we are using different disk here. Due to its complex structure and high cost, it is not commercially available. So if you are maintaining this type of disk, so it is not commercially available. It's a complex structure and high cost. It is high cost, so that we are unable to buy it. Okay, so that's why we are going for RAID level 3. Here RAID level 3 strips the data onto multiple disks. The parity bit generator for the data would is stored on the different disk. Okay, the parity generator stored on the different disk. Okay, so the parity, this technique makes it to overcome the single disk failure. If single disk is failure, then we won't lose any data. Okay, so the parity, because of the parity generator, it is in the parity bit generator for data would is stored on the different disk. And coming to RAID level 4, in this level an entire block of the data is written on data disk, and then the parity is generated and stored on the different disk. Note that level 3, see, the level 3 uses the byte level stripping, whereas the level 4 are using the block level stripping. So both level 3 and level 4 requires at least 3 disks to implement the RAID. It needs 3 disks. Next, RAID 5. So RAID level 5 writes whole data blocks onto different disks. Okay, on different disks, but the parity bits generated for the data block strip are distributed among all the data disks rather than sorting them on the different dedicated disk. See, the parity is shared for all the blocks. So parity 1, parity 0 and parity 2 are shared. Okay, so the RAID 5 writes the whole data blocks onto the different disk, but the parity bits generated for data block strips are distributed among all the data disks rather than storing them on different dedicated disks. Extension of level 5. In this level, 2 independent parities are generated and fashion among the multiple disk, distributed fashion. See the diagram, you can understand. So RAID level 6 is the extension of RAID level 5, and in this level two independent parities are generated. Two independent parities are generated and stored in the distributed fashion among the multiple disks. Stored on the multiple disks. Okay, among the multiple disk, two parities provides the additional fault tolerance. Two parities are providing additional fault tolerance. This level requires at least 4 disk drives to implement the RIPE. Here 4 disk drives are needed. 4 disk drives are needed here. Okay, so that's about RAID level 6. Okay, so that's all about today's session. Wait a moment, I can download attendance. So please be practice the lab programs. Okay, in the next session I'll give you some lab programs. There is no much time, we need to practice all. Okay, I will give that programs also, then we can practice. Okay, we'll meet in the next session. We will discuss